Here we have our question of the week. So the question is, we have to find the equation of the parabola touching the x-axis at 1, 0 and y-axis at 0, 2. Okay. And we have also got a bonus task where we have to generalize this for a, 0 and 0, b. So at first, the question may look straightforward, but it can be quite challenging to solve because the parabola is not a standard one. A standard parabola will not touch x-axis and y-axis like this. So it must be a rotated or a general parabola. So we can, one way to solve this is like to assume the general equation of the parabola, but it involves a lot of variables. So very few information is given and a lot of variables, so automatically becomes tough to solve. Another way which you can solve is to find the focus and directrix. If you know the focus and directrix for any parabola, any conic, then you can find its equation. So these are the two methods which you can attempt and try to solve this. I will share the solution just next. So the method 1 is assuming the general equation of a conic or parabola. So it is ax square plus by square. I'm using capital letters, so we will not get confused with this a and b, plus 2hxy. Let's use small letters for remaining, plus 2gx plus 2fy plus c. So this is the general equation of a conic. For parabola, h square is equal to ab, or we can rewrite h is equal to square root of ab. So we can use this, we will get an equation for a parabola. Now what we can do, that it touches the x-axis at this point, at a particular point. So we can put y is equal to 0. We can put y is equal to 0 and get a like quadratic, a good quadratic in x. And this has only one root. Only one root, that is x is equal to a or 1. Let's use this method to solve for general equation, and then we can just substitute a is equal to 1 and b is equal to 2 to get the answer. So one root is x is equal to a, and we have only got one root. So what is the condition for a quadratic to have only one root? The discriminant should be equal to 0. Yeah, so discriminant is nothing but here 4g square minus 4ac. Yeah. So yeah, so here we can get another relation, and we can also get a relation that x is equal to a satisfies this equation. We can use same thing by putting x is equal to 0. We will get another set of equation, and from there we can eliminate all these variables to get a like general equation. So you can do it yourself. This is your task. You will get a feel for the answer and a good practice. What I will do is solve this using method 2, finding the focus and directrix. And this will involve focus and directrix. And this will involve using various properties of parabola, which makes it quite good question for JEE Advanced. Like the problem with this method is you will not get focus and directrix. We will get the equation, but from there finding the focus and directrix can be quite challenging. But the question may ask like find the equation of the parabola, also find the focus, also find the directrix. So this method now becomes pretty good. So I will use first find the focus and first find the directrix, and you will get a lot of properties of parabola revised. So let's first draw the parabola for this situation. So we have got y-axis and x-axis. I hope you know how to find the equation of parabola. If we know the focus and directrix, just use PS is equal to PM. If we know focus and directrix, then any conic can be found. Just PS by PM is equal to E. For parabola, eccentricity is equal to 1. Yeah. So touches the x-axis at 1, let's call this as 1 unit. This is 1 unit and this is 2 unit. So this is, let's name it, or let's leave 1, 0, 0, 2. Let's draw a good parabola. Yeah, I hope this looks good. So this is our parabola. Let me just clear it. Yeah, so this is our parabola. So now we have to observe a few things. Like this is x-axis and this is y-axis. These two are tangent to the parabola, touches the parabola at one point. And we know x-axis and y-axis are perpendicular to each other and intersects at origin, that is 0, 0. Now we can already see some properties like two tangents to a parabola are perpendicular. So this point must lie on the directrix. So this point must lie on the directrix. So let's draw a directrix. So must lie on the directrix. And we can use also another property like these two points at which the tangent touches the parabola. Then this line segment must be the focal chord. Yeah, this must be the focal chord because of the property like from a focal chord, if we draw two tangents, then the tangents must be at 90-degree, or vice versa. If from a point on directrix two tangents are drawn, then the line segment joining these 2 points must be the focal chord. So yeah, this is quite famous property of focal chord of parabola. So we got the focal chord. There is also another property which we have to use, like this portion of the tangent, and if we draw from here a line to the focus will lie on the focal chord. So if we draw a line from here, then this will make a angle of 90-degree. This is another quite famous property, like portion of tangent intercepted between the, like this portion will make a 90-degree to the focus. Yeah, so this is our point, this is focus, so this will also make 90-degree. Okay, so we have to find focus. So now so we can already see how can we find focus. Like if this is a line and this is also another line. So focus is the point of intersection of these two lines. So let's name a few things. So let's call this B. Let's give the name here. B, A, and let's call it O for origin. So now we can find the focus. To find the focus, let's write the equation of MAB, or equation of AB, equation of line AB. So we can directly use the intercept form. Yeah, x by 1 plus y by 2 is equal to 1. So we will get what? We will get 2x plus y is equal to 2. Yeah, so this is our equation of this line AB, and we can also see slope. Slope of AB is nothing but minus 2. Yeah. So since this AB is perpendicular to OS, so we can, to find the equation of OS, we got 1 point, but we also need its slope. So slope of OS, this implies slope of OS. Since these two are perpendicular, so it must be half. Yeah, acute angle also we can see. So now we can write equation of line OS. So it is, since it passes through origin, so the equation must be of the form y is equal to mx. So we already got the m, y is equal to half x. So S is nothing but the point of intersection of this. So from 1 and 2, we have to just find the point of intersection. What we can do, substitute x is equal to 2y. So x is equal to, we can write 2y. So it becomes 5y. 5y is equal to 2. So I get y is equal to 2 by 5, and x is nothing but like twice of y. So x is equal to twice of this, 4 by 5. So we got our focus S, 4 by 5 and 2 by 5. So this is one thing. that we have got. Now can you think how to find the directrix, equation of directrix? Focus task is done. We have to find the equation of directrix. So one thing that you can do, you can use another property that if we take the image of the focus along any tangent, then it must lie on the directrix. This is another property, that if we take the image of focus along any directrix, along any tangent, then it must lie on the directrix. So we already got one point which lies on the directrix. So if we can find another point, then we will get the equation of directrix. So you can use that. There is also another small method with which we can get the equation of directrix. So like we already got a point. So if we know the slope of the directrix, then we will get its equation. So how to find the slope of directrix? Like we can use another property, that if we find the line joining the midpoint of focal chord or any chord. So the line joining the midpoint of chord, this is a chord. So let's call this M. So what will be this coordinate? It is 1/2 and it is 1. So if we draw this point from where two tangents are drawn, and if we join the midpoint of the chord, then this must be parallel to the axis. So another property states that OM must be parallel to the axis of the parabola. This is another useful property. It may not be known to many students, but this is also the property of parabola which you can use. Like it's there in the diameter. If we try to find the diameter of the parabola, there such property can be used. So yeah, OM is parallel to the axis. So axis will be like this somewhere. It does not pass through. It will not necessarily pass through O. So axis is like this, and it will be parallel to OM. Yeah, so you can generalize this. Let me draw a better axis. So here we have drawn the axis of the parabola, which divides the parabola in two equal halves, and we can see that OM is parallel to the axis of the parabola. So the slope of OM is easy to find, like y2 minus y1, x2 minus x1. So 1 minus 0 is 1, and half minus 0 is, so y2 minus y1, x2 minus x1 is 0. So it becomes 2. So slope of axis is 2, therefore, and we know that directrix and axis are perpendicular to each other in parabola. So the slope of directrix becomes like m1 m2 should be equal to -1. That's the condition for perpendicularity. Two lines to be perpendicular, so slope of directrix is m is equal to -half. Yeah, so now we have got everything to find the equation of slope. Therefore, equation of directrix we can use, again directrix passes through origin, so it will be of the form y is equal to mx. The slope is -half. Yeah, it looks good. So y is equal to -half x, or we can rewrite this as 2yx plus 2y, just cross multiplying and rearranging, and we will get this. So we have got both focus and directrix. Now we can use the basic definition to find equation of any conic. Like if this is the parabola and we got our focus 4/5, 2/5, and this is the directrix. So let's take any point on the parabola, HK. We have to find this locus. So we drop a perpendicular, PM. So in parabola, PS is equal to PM, and directrix is our x plus 2y is equal to 0. So therefore PS is equal to PM. So PS is our h minus 4/5 square plus k minus 2/5 square PM, the perpendicular distance, so h plus 2k square root of the coefficient 1 plus 2 square, it is 5. So yeah, PS, it should be a square root. In distance formula there is a square root also, so we can anyhow square both sides and just simplify it. So let's just square both sides and let's rewrite. So I am squaring both sides, so this is 5h minus 4 whole square plus 5k minus 2 whole square by 5 square, and this is h plus 2k whole square by 5. So let's cancel this out and we can open it. So let's open 25h square plus 16 minus 20 and twice also, so 40. So it becomes 40h plus 25k square plus 4 minus 10 minus 20k, and 5 goes there, so 5h square plus 4k square plus 4hk, and we can just divide it by 5. You can see 16 plus 4 is 20 and everything is divisible by 5 in LHS. So let's divide it by 5. Therefore 5h square minus plus 5k square and minus 40, so minus 8h minus 4k plus 20 divided by 5 is 4, and h square plus 4k square plus 4hk. 5 we have divided it by 5. Now we can just rearrange. Let's take everything in LHS. So 4h square plus k square minus 8h minus 4k plus 4 and yeah is equal to 4hk. So and let's keep 4hk also in here minus 4hk. Let's rewrite this as minus 4hk plus 4 is equal to 0. So this is our one answer. We can just substitute h and k with x and y to get the final equation. So x square, 4x square plus y square minus 8x minus 4y, k becomes y, 4xy plus 4. So this is one acceptable answer. We can also simplify this. Like you can see there are some whole square terms. So what we can do, you can see this becomes, we can rewrite this as 2x plus y and we have to choose minus 2 whole square. Yeah, so now you can see if we open it, so we will get 4x square y square plus 4 square, then we will get plus 4xy, but we have minus 4xy. So what we can do, just add plus 4xy, then balance it with minus 4xy. So we will get a minus 8xy remaining. I hope you get this. If you do the calculation, then you can understand this part. Then minus 8x, do we have minus, then we will get minus 4y, we have minus 4y, we have minus 4y. Then we will get minus 2 into 2x into 2 minus 8x. I am using this formula. I hope you will get. Using this formula, you can rewrite this in simple form, 2ab plus 2bc plus 2ca. So I am getting this, and this part is remaining, minus 8xy part remain. We can rearrange and rewrite it like this, 8xy. So this is one answer, and we can generalize this. What we can do, we can divide it by you can see that 2 and 1 hour was our variables. The tangents, the parabola or the tangent, the point of contact is 0, 2 and 1, 0. We can see that 2 and 1 is there. So what we can do is divide by 4. So this becomes x plus, dividing it by 4, so it becomes 2 whole square, y by 2 minus 1, and after dividing it by 4, we get 2xy. Here it should be whole square. So this is the final result. You can answer it like this, Also, like this is also accepted, like this any of this answer is accepted, but this is a generalized form. Like we can rewrite it like x by a, 1 was our the point of touching in x-axis, y by b minus 1, and how to get 2xy. So here we cannot like guess automatically. If you derive from the general equation, then you will get the general formula like this: 4xy a into b. A into b is here 2, so 4 divided by 2 is 2. So this is our final general form. This is the general equation for any parabola which touches the x-axis at a comma 0 and y-axis at 0 comma b. Let's check this formula. Let's visualize this formula if this works, and we will also visualize these properties. So let's go to the visualization part. So here I have opened the GeoGebra where we can visualize different graphs. So what we have got, x by a, which is 1, x plus y by 2 minus 1 whole square is equal to 4xy by 2, or here it is 2xy. Yeah, so now you can see that it definitely touches. Let me draw the axis or the point of intersection. So it touches at 1 comma 0 and 2 comma 0. We got our point of intersection. Yeah, so this parabola is correct. So now we can, what we can do, we can visualize the properties like the midpoint of how we have found the focus. Like these two lines, x axis and y axis, intersects at 90 degree. Yeah, so this AB must be a focal chord. So let me draw this line segment, join this AB. So we got our focal chord. Let me just eliminate the variables. Yeah, so it makes a 90 degree, and if we draw a 90 degree from here, if we drop a perpendicular, and passing through this, so this is our origin, and here this should be the focus according to the property. This line should be the focus, and we can get its point of intersection by solving these two lines. Let's see if we got, yeah, h. This is our answer. Like it was coming out to be 4 by 5 and 2 by 5. Here it is, you can see 0.4 and 0.8, which is 4 by 5 and 2 by 5 itself. So focus, we have got the focus correct. Next we have to find the equation of directrix. So what we can do is like take image of this focus from this tangent, then it will land on the directrix. This is one method. So let me show you that. So I'm just going to reflect this point about this line. We got this h dash, and if we just join these two lines, then we will get directrix. There is another method also, like what we have done. First take the midpoint, like we have taken the midpoint of this and this, and if we join this with the midpoint, then it must be parallel to the axis. So let's join this, and it should be parallel to the axis. So we will get, and if we check this perpendicular, if this is perpendicular to our line, so let's check the angle. Yeah, indeed you can see that this makes 90 degrees. So this is parallel to the axis, and axis is parallel to our original directrix. We can also draw the axis, like axis should be parallel to this, like draw a parallel line parallel to this and passes through focus. So you can see that this axis should be perpendicular to also directrix. So yeah, this is the visualization. I hope it is clear. We got our equation of directrix. It is directrix. Yeah, indeed we have to divide by 0.4. You can see the slope, it is coming out to be minus half. Yeah, minus half. And this is our focus. whose coordinate is this, and we can use PS is equal to PM. Or there was another method like take the image. We have taken the image of H along any of these tangent, it will lie on the directrix, and if we have found 2 points on the directrix, then we can get the equation of directrix. So I hope everything is clear. This is a very beautiful parabola. So yeah, this is our final answer. We have also visualized this. We have also, using this method, found the focus and directrix. And this is a pretty good question, like the property part. Many different questions can be answered. And I hope you got the solution of this question and found the visualization helpful. That's it for today. Thanks for watching.